All right, welcome to week 4, practice problems. We're going to get started here. Which of the following functions does f of x equal f of negative x? Now remember, there's a long kind of process of taking f of x and replacing x with a negative x. So you can compare f of x to f of negative x, but I think this process is a little complicated. So I think instead, try plugging in f of 2 and then also looking at f of negative 2. 2 is an example. You can pick anything, 1 or 3 or 4. So let's look at choice A. If I plug in 2, I get 3 times 2 minus 1. That's 6 minus 1. 6 minus 1 is 5. So f of 2 is 5. Let's do the same thing, but let's try negative 2. So f of negative 2. So we're putting a negative 2 in for x. So 3 times negative 2 minus 1. Again, we're looking at choice A. 3 times negative 2 is negative 6. Negative 6 minus 1 is negative 7. Are they equal? No. Okay, and that's what we're trying to show, is that the f of x equals the f of negative x. So it's not A. Okay, we can say it's not A. Let's try B. 3 times, let's pick a 1 here because a 1's actually easier to use. 3 times 1 to the third minus 1. So 1 to the third is 1. 1 times 3 is 3. 3 minus 1 is 2. Okay. Let's plug in a negative 1 and see what we get. So if we do the same thing, but we plug in a negative 1, negative 1 to the third is negative 1 because it's an odd power. So 1, 2, 3 negatives make a negative. Times 3 is negative 3, and negative 3 minus 1 is negative 4. So you can see that we don't get the same thing. So that means it cannot be choice B, because we're trying to show when f of x is equal to f of negative x. So for any x, this should work. So we're just picking random x's. Let's try C. Let's try, I don't know, we'll plug in negative 3 this time because it's a pretty simple equation. So if x is negative 3, we have negative 3 plus 7, right? We're plugging it into C. We get 4. When we plug in the opposite version of negative 3, we plug in a positive 3. 3 plus 7 is 10. Okay, what I'm doing is I'm taking this equation, I'm replacing x with 3 and negative 3. I pick one positive, one negative, and compare the two. If they're not equal, then we're going to say that f of x did not equal f of negative x. So we're saying it's not C. All right, let's try D. X squared, we can pick something like 2 for x. So 2 squared minus 3. Okay, we're going to compare that to negative 2 squared minus 3. Plugged in a 2, and we plugged in a negative 2. When we do 2 squared, we get 4, and 4 minus 3 is 1. When we do negative 2 squared, we get 4, and 4 minus 3 is 1. So in D, f of negative x equals f of x. Okay, so that problem took a little while. Okay, so there's probably some shortcuts that we can take. So let's look at some shortcuts that we could have taken here. All right. First of all, I could have done the same thing I did by plugging in numbers. I could have done on my calculator. So I could have looked at y equals and then typed in the first equation, 3x minus 1. Oops, 3x minus 1. All right, when I look at the table, what we're doing is I've got my table all messed up, so I need to go back to table setup. So second window, that's table setup. Let's start with negative 2, and let's go up by 1 each time. Now if I look at my table, we're going to start at negative 2 on the x, and we're going to go up by 1 each time. Look at negative 2 versus positive 2. You see how they're not equal? There should be some symmetry here. Negative 2 gives me a negative 7, and 2 gives me a 5. That means that f of negative 2 is not the same as f of 2. Okay. Also, remember, look at your graph. Remember, we said that this is an even function, so it should be symmetrical about the x-axis, the y-axis. So it should be like a mirror image on both sides. For example, this, or this, or this, or this, things like that, things that are symmetrical. So this is not symmetrical, so it can't be it. All right, the next one is 3x to the third minus 1. Let's do 3x to the third minus 1. Okay, if we look at the table, does negative 2 equal 2? Nope. Does negative 1 equal 1? Nope, doesn't work. And again, looking at the graph, you're going to see that that is not the same thing on both sides of the y-axis. All right? All right, so let's go to ultimately to our answer, which was x squared minus 3. So if I typed in x squared minus 3, you would see, first of all, from the graph, it's symmetrical on both sides, okay? That means that it's even. Also from the table, just look at when I plug in negative 2, I get a 1. When I plug in 2, I get a 1. When I plug in negative 1, I get the same thing as when I plugged in 1, right? When I plug in 5, I get the same thing as when I plug in negative 5. See that symmetry? That's what it means to have f of x equal f of negative x. All right, moving on. All right, let a, b be a point on the function f of x equals x plus 1 divided by x minus 3. Which of the following is true? Okay, so if you look at your answers, it's saying a can't be this and b can't be this, okay? The only thing, if a is the x coordinate and b is the y coordinate, the only restriction here is that if you look at this function, right, x minus 3 on the bottom, that has the ability to divide by 0. If x was equal to 3, we would be doing 3 plus 1 divided by 3 minus 3, which is 4 divided by 0. That means we're not allowed to have x equal to 3, okay? Now remember, x in our point here is the a. Okay, the x coordinate is equal to a. So that means a is x. In other words, a cannot equal 3. So we're going to say a cannot equal 3. This is a question that kind of, it's a domain question, but then they add that little twist of putting a little, some variables in there, a and b, not just x and y, to kind of throw you off a little bit. But that's actually a pretty simple problem if you think about it. All right, moving on. What is the domain of f of x equals square root of 5 minus x? Okay, so a couple options here. You could totally graph this problem, okay? Y is equal to the square root of x, excuse me, 5 minus x. You could graph this, and you could, you know, zoom, or you could look at a table maybe, right? Look at your table, and what do you notice? All these x numbers are okay because we all get a y number. All right, all these x numbers are fine. We get y numbers. Nothing crazy happens. Okay, domain restrictions are when something really crazy happens. Except for right here, when x is 6, we start having issues. Okay, so it looks like x equals 5 is okay. I can plug in 5 into the function. It gives me back a 0, but I can't plug in 6. So let's look at why that works. I can plug in 5 because 5 minus 5, right? 5 minus 5 is square root of 0, and it's okay to take the square root of 0. But as soon as x is equal to 6, then I have the square root of negative 1, which doesn't exist. Okay, so basically x can be 5, but nothing bigger. If x is bigger than 5, there's a problem. So which one of these does that relate to? X is greater than 5? No, x can't be bigger than 5. Remember, x has to be smaller than 5. So x can't be greater than or equal to 5. Those are both out. X is less than 5. That is true, but remember, x is actually allowed to equal 5, like we saw in this example here. So it's missing a little piece. We want the answer E, x is less than or equal to 5. Okay, now there's a way to do this by hand. Okay, you know when you take the square root, you have to have 0 or a positive number. You can't do a negative. What that means is what's under the radical has to be greater than or equal to 0. So let's put whatever's under there. The 5 minus x has to be greater than or equal to 0. And then if we solve this inequality, right, if I add x to both sides, I get 5 is greater than or equal to x. And then I always like to write it with the x on the left side. You just make sure you flip everything around. And there's our answer. Okay, so if you set what is underneath the radical greater than or equal to 0, you can always work these problems algebraically. okay? But there's some other ways to do it. Think about graphing it or looking at a table, right? So actually, we didn't really look at the graph. Let's look at it real quick. I think my zoom is messed up. So there we go, back to regular zoom. As you can see, all the X values are on this graph, right? Except for when I get past X equals 5. Once I get over into this region, there's nothing there. And that's my domain, all the possible X numbers. So pretty much everything less than or equal to 5 is on the graph, okay? All right, what is the range of f of x equals negative 1/2 times x plus 1 squared minus 3? Okay, so remember, domain and range, we can always graph these things. So let's look at this if we graph it. So negative 1/2 times parentheses x plus 1. We want to square that, and then we want to subtract 3. Okay, we look at a graph. Remember, range is all my possible y values. So up here at the positive y values, the graph is nowhere to be found. Okay, so there are no positive y values. Basically, the lowest or the highest we go is down here at -3. And then everything below it exists, right? This point right here exists as a possible y value because this coordinate has that y value over here. So basically everything here. So from -3 down. So that tells me y has to be less than or equal to -3. Make sure you don't answer y is less than -3 because it's actually equal to -3. And again, one way to see this would be to look at your table. You got to kind of explore here. As you can see, look at all my y values, right? Definitely everything negative is on there. What's the highest? It goes up to -3, and then it goes back down. So nothing above -3. Okay, that's another indicator that that's the highest point. All right, alternately, in another day, we're going to teach you how to find the vertex and know whether this thing opens up or down. That's another great way to look at the y value of the vertex because it is the highest or lowest. And highest or lowest is what we're talking about when we're talking about range. All right, if f of x equals x squared minus x, then what is f of x plus h? All right, so in this question, we are given the function is x squared minus x. Now remember, if I put in anything in here, doesn't matter what it is, that thing gets replaced in every single x that I see. Whatever the thing is, doesn't matter if it's crazy, if it's a smiley face, it doesn't matter. You put that in for every x that you see. So in our case, we have an x plus h. So all you have to do is plug in x plus h inside for every x. Okay? Now, of course, none of our answers look like that because we're supposed to simplify this thing. So what we can do is we can actually square x plus h. Don't forget, when you square something, you have to multiply it out twice. And that's what we would do there, is multiply it out twice. It's not, you cannot square the x and square the h. It doesn't work that way. Okay, we have to do this whole process of distributing the x times x is x squared, x times h is xh, h times x is xh. Again, I write it like that because I want to see those pairs of as equal. I want to see them as like terms, excuse me. I want to see them as like terms. So if I wrote them as xh and one as hx, I might not see that, okay? Then I distribute, sorry, I've distributed the h to that. Now I have to distribute the h to that. So now I get plus h squared. Don't forget, you got to distribute your negative sign, so minus x minus h. Then just put your two common terms together. You have two of these xh's. Okay, that problem is really, really easy minus two things. Sometimes people forget what function notation even means, and then some people forget to multiply out that squared. Other than that, this problem is pretty easy. There is some algebra stuff like distributing a negative, combining like terms. Other than that, it's just showing that you understand function notation. Okay, so we are going to go with C. All right, next question. If you transform the function g of x equals x squared by shifting each point on the graph left 3 units and down 4 units, what will the new equation be? Okay. So remember, when you shift left or right, that's always with the x according to that awesome story that I told. Okay, so if you have x squared, you want to shift left or right, you're going to put a number inside the parentheses with that x. Okay, the question is it going to be a plus 3 since we're shifting left 3, or is it going to be a minus 3? That's the question, left 3. Don't forget, when you're with your x, it's backwards. So normally on a number line, right, when you look at a number line, here's 0, negatives are to the left. So you think left 3 would be negative 3, but it's backwards, meaning you have to actually add the 3 inside the parentheses. That takes care of our left 3. How about the down 4? That up or down is not with the x, so that's going to just tag on to the end. So I'm either going to add 4 or subtract 4. When it's not with the x, it's normal. So that means we add a little minus 4 at the end. That's going to actually shift it down. Now, if you weren't sure, this would be an easy time to just graph the thing and say, does it look like x squared, which is a parabola, except it's left 3 and down 4? That's a pretty quick check if you weren't sure of yourself, okay? So we're going to go with B, x plus 3 squared minus 4. All right, find f of negative 3 given that f of x equals negative x squared plus x. Okay, so first off, I'm going to show you how to do this problem wrong. Okay, I'm going to show you how to do this problem wrong. This says negative x squared, and x is actually negative 3, right? Because we replace the f of x with f of negative 3. So we're saying x is equal to negative 3. Again, that's what function notation tells us. So I'm going to plug in negative 3, but it's a negative x. So a negative 3 is positive 3. See what I did there? There's a negative in front. There's a negative in the x. They combine to make a positive. I square that, and then I add this negative 3. Now, of course, plus and minus turn into a minus together when you have those double signs. So 3 squared is 9. 9 minus 6 is 3. All right, now, normally they would have that answer in here in your answer choices. Okay, they kind of expect you to make that sort of that wrong move. So what did I do wrong here? Well, what I did wrong is it says negative x squared plus x. So I should plug in a negative 3 right there. Right? Notice how I'm using parentheses. Safe, always, always safe, especially with negative numbers, to put that in parentheses. Okay? This squaring has to happen first. Just order of operations. You got to square first and then put the negative on it. Okay? So I should square my negative 3 to make a positive 9. That's where I went wrong. Then I should apply the negative. So negative x squared, when x is negative 3, is actually negative 9, not positive 9 like I wrote up here. Okay, it's definitely negative 9. So then I still add the negative 3. I still do subtract 3, and that does give me negative 12. So my answer choice is going to be A, negative 12. Okay. You could do some things here with your graphing calculator. Remember, what they do is they give us a function, and then they tell us that x is negative 3. If you're told a function, you can always graph it. Okay, we could put negative x squared plus x, and then graph it. Okay, when I look at x equals negative 3, boom, boom, boom. When x is negative 3, what is the y value that's associated with it? Something negative, and it looks like it's bigger than negative 10 or pretty close to negative 10. So it's really only got to be A. All right. Remember, you could also look at your table and realize that when you plug in negative 3, you get negative 12. Okay, that's obvious right there. One quick thing, if you're ever trying to plug in a number, you can do it by doing second calculate and then value, number 1. Okay, you just hit enter there, and it says x equals. And you say, well, I want x to equal negative 3, and it's going to tell you that y is equal to negative 12. This is especially handy if you have to plug in something weird like 3.52, right? That's not going to be on your table. When you look at the table, 3.52 is not going to be on there. Of course, unless you set it up that way with table setup, you could make it start at negative 3.52, right? What would happen if I did negative 3.52 and then I go up by 1? Now, if I look at my table, it starts at negative 3.52 and it goes up by 1. But I want to get this negative 15.9. Second, calculate number 1, the value. Basically, it's saying, what number do you want me to plug in for x? And you say, well, I want you to plug in negative 3.52. You hit enter and it will tell you that y value. Okay? All right, moving on. When does f of x equal 3? Okay, function notation, this is one of those problems that are very, very common. What do they tell you? Do they tell me what x is or do they tell me what y is? Remember, they have to tell me one of the two for me to find the other one. Remember, f of x equals the y number. So what did they tell me? They didn't tell me x, because I still have an x here. They told me that y is equal to 3. So they're saying y is equal to 3. So you have to think, where along this graph is the y number equal to 3, right? Here's some choices. It says -3. Remember, we're answering for x. We're saying x is equal to -3, and at the same time, the y is 3. So where is that? -3. Here's the place on the graph, right? Remember, you have to be along the graph here, because we're talking about f, right? And this graph is f. So when I'm at -3, I'm at 0. -3, 0 is one of my coordinates. Is it true that at f of -3, it equals 0? Yes. Does it equal 3? No. So that's not our answer, right? You can see when x is 0, you're at this point here. This is the coordinate 0, 3. So yes, f of 0 equals 3. It's the only place where the y number is equal to 3 up here, okay, is when x is equal to 0. So remember, that's what they're asking for. When they say f of x equals 3, they're saying the y is 3. Now you tell me what x goes with that. Okay? Pretty standard function notation problem. All right. If f of xy equals 3x minus 2xy, find the value of f of 2, -2. All right. This is the same thing as regular function notation. There's just 3 variables. There's a z, which is this thing here, and then there's an x and a y. So we know that x is 2 and y is -2. All we're doing is evaluating. So we plug in x equals 2 minus 2 times x times y, right? What I did there is I found this function, f of x y equals this. So what I'm doing is I'm finding f of 2, -2. I just plug in 2 for x and -2 for y. So what do I get when I simplify that? 3 times 2 is 6. Okay, I want to subtract. 2 times 2 times 2 is 8. But think about this. I'm subtracting a 2 times a 2 times a -2. That makes that a -8. So, or you can think of it as a -2 times 2 times -2. Either way, these two negatives are going to cross out and make a plus. So really, I'm evaluating 6 plus 8. Not a terribly difficult problem if you understand what they're asking for. Okay, so function notation gets really scary sometimes for students, but just don't be worried about it. It's something that's very doable. All right, so we're going to say our answer is D, 14. All right, if f of x equals x plus 7 and g of x equals x squared minus x, find fg of 3. All right, so remember fg of 3 is really f times g. So I have 2 ways of doing this. I can plug in 3 first, then multiply f and g. Or I can multiply f and g first and then plug in 3 for x. Okay? Either way works. So let's try plugging in 3 first. So I get f of 3 is 3 plus 7, which is 10. And then I get g of 3 is 3 squared minus 3. So 9 minus 3 is 6. Then I multiply them together, okay, because I'm doing fg, which is f times g. That gives me 60. That was pretty easy, okay? I think this way is probably the easiest way to do it, but let's just see how to do it the other way too. First off, we're going to multiply f times g. So I've got f. I want to multiply that by g. I have to distribute here. X times x squared, that's x to the third. X times negative x, that's minus x squared. 7 times x squared is a plus 7x squared, and 7 times minus x is minus 7x. Got like terms. I get x to the third plus 6x squared minus 7x. So Plug in 6 now, or excuse me, plug in 3, because we're finding f of g of 3. Okay, so 3 to the third plus 6 times 3 squared minus 7 times 3 is going to give you 60. Okay, again, I think finding f of 3 and g of 3 and then just multiplying them together is probably the easiest here. Okay, so our answer is C, 60. All right, if f of x equals x plus 7 and g of x equals x squared minus x, find f of g of 3. All right, so this is a composition of functions. So I have two choices. I can find g of 3 first, and then plug in that number into f. So in other words, whatever number I get, remember g of 3 is a y value, so I'm going to get back a number. I can plug that into here. Okay, this is probably the easiest way as well. So find g of 3 first. Remember, the g is the second letter, and that's where we start with this problem. So find g of 3, then whatever you get back, plug that in for x in f. All right, the other way would be to actually find f of g. Figure out what that actual function is, and then plug in 3 for x. All right, let's try it the first way. G of 3. So g of x is x squared minus x. That means g of 3 is 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. Then I take that and I plug that into f for all the x's. Okay, so I have to re-evaluate. I'm doing this thing twice. So f of x is x plus 6, excuse me, x plus 7. Don't forget, I have to use my new number. I have to use 6 here. So f of 6 is equal to 6 plus 7, which is 13. Now, so many people are going to do this maybe right, and then they're going to find f of 3. F of 3, you would just ask for f of 3. Why would you do all this composition stuff, right? So if you're asked to find a composition, find g of this, find the second letter evaluated at the number, and then plug that new number that you get back into the new function f, the original function. All right, let's try finding f of g. So remember, f of g means I'm shoving g into f. So I'm going to write f, and then I'm going to shove the entire thing of g inside for every x that I see. So I'm going to shove the whole function inside here. It's an x. All right, so I get x squared minus x plus 7. This is the function f of g. So if I want to find f of g of 3, I just plug in a 3. 3 squared minus 3 plus 7. 3 squared is 9. 9 minus 3 plus 7 gives me 13. So it's kind of the same thing. It's just a preference. I think finding g of 3 first is the easiest. And it helps you understand when there's a graph what you're doing, right? If here's f and here's g, when you find g of 3, you're finding this point, and then you're taking that new y value and plugging it in for f. So it kind of helps you see with that as well. All right, if f of x equals 3x minus 12 and g of x equals x squared minus 7, then what number is not in the domain of g over f of x? All right, so first thing we got to find g over f. So g over f. This is the function g over f. Okay, we've created this new function by dividing. So what it says, what number is not in the domain? Well, do I have any way of square rooting and getting a negative number? No, there's no square roots to be found in this function, so we're not worried about that. Do we have any logarithms where I could do log of 0 or log of a negative number? No, I don't see any logarithms, so we're not worried about that. What are we worried about? We're worried about dividing by 0. This is a big giant fraction, so it presents the opportunity of dividing by 0. So what number for x is going to make us divide by 0? In other words, when I plug in a number here, what makes this whole bottom equal 0? And we don't care about the top. Top can be 0 all at once. The issue is dividing by 0, not 0 divided by 0. So we want to know when this 3x minus 12 equals 0. So if we set up that equation, we'll find out when that happens. Okay, we add 12 to both sides. We get 3x equals 12. and realize that x is 4. Once I divide both sides by 3, I get x equals 4. That means x equals 4 is not in our domain, because when I plug that in, I'm dividing by 0, there's a problem, okay? And the problem numbers are numbers that we say are not in the domain because it causes some kind of issue, okay? Alternately, I suppose, this is kind of out there, but, you know, it would work. What if we did this? What if we plugged x squared minus 7 into our graphing calculator? Okay, over 3x minus 12. Let me look at the graph, okay? So the number square root is 7. That's a weird number, but it's a little bit less than 3. So it's right about here somewhere. That point exists on the graph. So there's a point out there that has that number, square root of 7, as its x value. 3. 1, 2, 3. Yep, 3 exists. It's right here. 3 is a possible x number. 4. 1, 2, 3, 4. I don't see 4 anywhere to be found. And if I zoomed out, I would still see that there's an issue here with 4. Okay, 7 and 14, 7 exists and 14 exists. So look at the table. Of course, now I've got my table all messed up. So go back to table set. So second window, we want to start at 0 and we'll go up by 1s. Okay, so if I look at my table, all these numbers here, see how they all have y values? That means all those x numbers were okay. Those x numbers were able to be plugged in. The only problem is there's no 4. There's an error because when I plug in 4, I'm dividing by 0. So the calculator knows that and it says, oh, there's a problem with 4. That's how we find our bad number. That number is not in the domain. It does not give us a number. All these other numbers, even though they're kind of crazy, they're fractions and stuff, that's okay. So we're okay with that. All right. Alrighty. Next question. Find h of g of x if h of x equals negative x minus 10 and g of x equals root x plus 2. All right, so this question is asking us to find the actual function when you compose g with h. So we're going to shove g, or excuse me, yeah, we're going to shove g inside of h. And you can see that when it's written in this form. It's very clear that g is shoved inside of h. So basically, we want to write h, but instead of every x that we see, we're going to replace that with the entire function of g. We're going to shove the whole thing inside there. So negative root x plus 2 minus 10. Okay? When we shove it all in there, just like when we evaluate, when we find f of blah, 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 we just put the number, we replace x with that number. But we're just replacing it with an entire function. That's basically all we're doing here with composition. Okay? That one was easy if we know how to do composition, so we know the answer is D. Now they're going to give you answers that look sort of similar, or maybe they're going to give you ones where you shove h inside of g. Right? Don't do that. Don't put this whole thing inside of here, because that's probably one of the answers they're going to give. Okay? So watch out for that. All right, if f of x equals square root of x and f of g of x equals the square root of x squared plus 4, which of the following represents g of x? All right, so on this problem, they don't give us f and g. They give us f and the composition f of g. Okay, so how does f change, right? You notice how we see that g was shoved inside of f. So f was just the square root function. So what they did was they took that and they replaced that x that was inside the square root that we had right here, and they replaced it with this x squared plus 4. That means g was x squared plus 4. It's the thing that they shoved inside of f. Okay, so this one, I don't know what happened to my e, but there is no e. This one is d x squared plus 4. It is the function that had to be placed inside of f. Okay, that one's easy once you've seen that one a couple times, and this is actually a problem I've seen on a lot of practice tests. So hopefully you'll get one like this and you can knock it out of the park. All right, which of the following functions is odd? Okay, so let's look at A first. A is even, right? It is a mirror image of the y-axis. The same thing on the left as is on the right, okay? Look at choice B. B is the same thing on left and the right, okay? Now E is a weird one. E is like a reflection across X, and we don't even talk about that. That's not even a thing. They're trying to confuse you on that one. Okay, so it's definitely not E. Not A, it's not B, it's not E. Look at D. D actually is what we call rotational symmetry. So if I took this piece and I rotated it all the way around, it would actually look like this other piece. Okay, if you took it and you rotated it around, it would actually connect up with that piece. But here's the problem with that answer. Which of the following functions is odd? So remember, functions pass what's called the vertical line test. And since this thing hits it more than once, that means that that is not actually a function. Okay, that leaves us with only one choice, C. So right here, if I took this and I rotated it all the way around, it would actually look like this. Okay, and notice like when X is, let's say, pretend this is 2, see how that's at positive 2? Well, when I look at negative 2, it's the opposite. Instead of being at positive 2, it's actually negative 2. Same number, opposite sign. Okay, all right. Given that f of x equals 4 times the square root of x, and g of x equals x over 3 divided by, or excuse me, x divided by 3 plus 2, find the value of f of g of negative 3. Okay, so we're finding f of g of negative 3. Now remember, just like the problem we did earlier, there's two options. I can find g of negative 3 first, and then I can shove it inside of f of x. That's probably the easiest way, so let's try it that way. All right, g of negative 3. Well, g of x is x divided by 3 plus 2. So g of negative 3 would be negative 3 over 3 plus 2. Negative 3 divided by 3 is negative 1. If I add 2 to that, I get positive 1. So that's g of negative 3. So then I want to take that and I want to shove it inside of f of x. So instead of f of x, I want to actually find f of 1. Whatever number you get back from g of negative 3. All right, so this is pretty simple. F of x is 4 times the square root of x. F of 1 would be 4 times the square root of 1. The square root of 1 is 1, so 4 times 1 is 4. So you could, if you wanted to, find f of g. F of g. So basically we're shoving all of g inside of f. So instead of writing f of x as 4 times root x, you'd find 4 of root the whole function g. Okay, now if I plug in negative 3 here, I'm going to get negative 3 over 3 plus 2. When I root that, I'm going to still get 1, just like I did earlier, right? Negative 3 over 3 is 1, excuse me, negative 1. Negative 1 plus 2 is 1. Square root of 1 is still 1. You still get 4, okay? That way it does still work. All right, find the value of f of xy equals 2x squared minus 2y, given that x equals 3y and y equals negative 1. All right, so this is a little bit of a tricky problem. It's very similar to the one we saw earlier, except they don't give us x as a number. So I can't just plug in x as a number, okay? I'd have to know what y is to know what x is. Well, I know what y is. Y is negative 1. So that tells me that x is 3 times y. And if y is negative 1, then 3 times negative 1 is negative 3. So that little step is a little added step there where you have to figure out what x is first as a number before I can actually evaluate. So when I find f of xy, I know x is negative 3 and y is negative 1. Now you don't have to write this, what I just wrote, but I'm just showing you that this is the x and this is the y that we're using. So I do 2 times x squared minus 2 times y. Don't forget, don't multiply the 2 inside there first. You have to do the order of operations here. So you're going to square the negative 3. That gives you a positive 9. 2 times 9 plus 2, right? 2 negatives there make a positive. So we get 18 plus 2. which is 20. And so our answer is E, 20. This kind of problem actually happens, this little ending here that they put on there. You have to sometimes use what you know, the information that you're given, to find something else before you're even allowed to do the problem. Okay, that's what the ACT is actually testing on. Whether you can take given information and extend it to solve things that you need to know. All right, for which values does f of x equal 2, given that f of x equals x squared plus 1? All right, so the whole thing here is this f of x equals 2, right? Remember, f of x is always equal to the y. So did they give us x or did they give us y here? They gave us y equals 2. So we're trying to find x, okay? So we have this function where we know that the y number is 2. So we put the y number equals 2. We got to figure out what number x has to be. So I can just solve this, right? Take away 1 from both sides. You get x squared equals 1. Well, when I square root x squared and I square root 1, square root of x squared is just x, and the square root of 1 is 1, and negative 1. Okay, this is a big star here. When you square root a number, you have to realize there is a positive and there's also a negative version. Because when I plug in 1 and I square it, right, just plug in 1 here. 1 squared plus 1. That's going to equal 2. What about negative 1 squared plus 1? Well, negative 1 squared is also 1, and when you add 1, you still get 2. That's why there's 2 different numbers that work here. It has to do with squaring a negative to make it the same as if it wasn't negative. So we're going to say D, both A and B, is our solution set. Okay. All right, which of the 2 following functions are inverses? F of x equals x plus 2 over 5. H of x equals 5x plus 2. And g of x equals x minus 2 divided by 5. Okay, so a couple options here. You could take f of x and find its inverse. Okay, I don't think you want to do that though. I mean, you could say that y, remember f of x is y, and when we do this, we usually just deal with the y's for a moment. You switch the x and the y. See what I did? I just switched the x and the y's. Now I'm going to solve for y. So I'm going to multiply both sides by 5. That gets rid of the divided by 5. I'm going to take away 2 from both sides. So I'm going to do that right here. I'm going to take away 2 from both sides. That gives me y equals 5x minus 2. Okay? So that tells you that f and its inverse is not there. So it either has to be h and g, or the inverses are not. There's E, the choice E, none of the functions are inverses is possible as well. Okay? I don't think that's necessarily the best way to do it. It does work, but I think a better way to do this would be to, actually, I'm not saying that's a bad way, because actually that process I could do one more time. Let's just go with that process. So now let's find the inverse of h. So remember, this is y equals 5 times x plus 2. If I switch the x and the y and then solve for y, right, I take away 2 from both sides. That gives me x minus 2 equals 5y. Divide out the 5, I get my inverse. So I see that y is equal to x minus 2 divided by 5, and that's what g is. So I think actually maybe this is a good way to do it, is to actually pick one and just find the inverse of it. And if you found the other one, then it matches, then you got it. Okay, so we're going to say h and g are inverses of each other. Now, the other way that you could have done this was to graph this. So let's just look at why h and g are inverses of each other. So first off, we can look at x minus 2 divided by 5, and then we'll also look at the function 5x plus 2. So you could graph all 3 of these. That's what I was thinking would be pretty quick and easy, would be to graph all 3 of these and see how they're mirror images of each other along the line y equals x. I mean, you have to kind of tilt your head sideways and see that. that they're mirror images of each other. So what I'm saying is, right, here's the line y equals x, here's the one function, here's the other function. If you kind of tilt your head sideways, you'll see that it's just a mirror image of each other. If you tilt your head sideways, it kind of looks like this, and it's easy to see, oh yeah, they're the same thing on both sides. All right? Okay, next question. Which of the following graphs represents f of x minus 4, given that f of x equals negative square root of x? All right, so this is a transformation. We want to find f of x minus 4. So we want to take whatever f is, and I want to shift it which way? Well, that x minus 4, that minus 4 is with the x. So when it's with the x, it's either left or right. In this case, it's going to be right 4 because when it's with the x, it's backwards. So remember, on a number line, if here's 0, you think negatives are to the left, but it's backwards, so it actually shifts it right 4. So first off, we just got to figure out what f looks like. F is negative square root of x. Now remember, square root of x looks like half a parabola on its side, right? It kind of looks like this lower half of a parabola isn't there, and so it's just half a parabola on its side. So negative square root of x would reflect it across the x-axis, which would turn it into this graph. So this is actually our graph of f. If I shift that 4 units to the right, it's going to look like C. Okay? Now, alternately, if you didn't go through that process of knowing what square root of x looked like and then thinking about what negative square root of x looked like, you could obviously use your graphing calculator. Just graph what f looked like, and f was the negative square root of x. And then basically shift it to the right 4. And you would see that it's got to be C. Okay? All right, that's it. Thanks again for being here. Appreciate it, and we'll see you next week.